How many bit is the linear address?
(32-bit).
Yes, that's correct. It is 32-bit. Do everyone agree with it? Linear address. See, remember this point. This will be useful for your oral also and your online exams also. Okay. So linear address is 32-bit, logical address is 48-bit, logical address contains selector and offset, selector is 16-bit, offset is 32-bit. Okay. What does the selector contain? What are the bits of the selector? Yes. What does the selector contain? See, revise the concepts. I've shared the PPTs with you. Read the PPTs because we don't know when your exam is there. Obviously, next month you have the unit tests in the first week. So that is there, but we don't know the final exams when they are there. So be prepared like, as per the timetable we will get, but you be prepared beforehand. Okay? Yes, what does the selector contain? Yes, Kiran, can you tell me what does the selector contain?
Segment.
What?
Segment.
Selector, does it contain segment? No.
Sir, request privilege level, it contains
Okay, okay.
tab indicator.
Table indicator.
Yeah, sir, table indicator. These two things, sir, and index.
Yes, and index. It contains index, table indicator, and RP requester privilege level. It is Krutika, not request. Okay, requester privilege level. How much is the RPL size? Requester privilege level is how many bits? Yes, student, start studying. Okay, it is 2 bits. Requester privilege level. It indicates the security information for the requester. If it is 00, it is the highest privilege. Kernel is at 00. If it is 311, it is least privilege. Application programs are at privilege level 3 and others are between them. Privilege level 0 is more secure than privilege level 1 and 1 is more than 2, 2 is more than 3. 0 is the most privileged. Okay. Then table indicator, what does it indicate basically? GDT or LDT. If it is 0, it is GDT is being accessed. If it is 1, LDT is being accessed by the selector. How many bits is the index in the selector?
15.
No, 13 bits.
13.
Total selector is 16 bits, TI is 1 bit, RPL is 2 bits. So 3 bits are used for that, 13 bits are used for selector. Okay. How many descriptors are there in GDT? Yes, how many descriptors are there in GDT?
8192.
Yes, 8192 descriptor. What is the size of each descriptor in GDT?
8 byte.
8 byte, that's correct. What does it contain? Yes, what does a descriptor contain? Segment descriptor. We have seen the format of segment descriptor, code segment descriptor, data segment descriptor. What does it contain? Yes, students. Yes, Ankita, can you tell me? What does a segment descriptor contain? Base address limit, that's correct. How many bit is the base address? Everyone be interactive.
32 bits, sir.
Yes, and how many parts is it divided into in the segment descriptor? Base address is divided in 3 parts, that's correct. How many bit is limit?
20.
Yes, that's correct, 20 bit. How many parts is it divided into in the segment descriptor? 2 parts, that's correct. Okay, everybody try the answer. And if you don't know the answer, please listen properly and remember it. Okay, what is the maximum size of GDT?
Sixty-four kilobytes.
Yes, that's correct. 64 kilobyte is the maximum size of GDT. What is the minimum size of GDT?
8 bytes.
8 byte, that's correct. What is the maximum size of a segment? Code segment, data segment. 1 MB if granularity bit is what? Yes, that's correct. If granularity bit G bit of the segment descriptor is 0, the segment to which it points is having maximum size 1 MB. And if the granularity bit is 1, it is page granular. Then what is the maximum size of a segment for that segment descriptor? 4 GB. That's correct. It is page granular. Each element in the segment is of 4 kilobytes. So 4 kilobyte into 1 megabyte, that it comes out to be 4 gigabyte. So if the granularity bit is 0, it is byte granular, maximum size of segment is 1 MB. And if the granularity bit is 1, it is page granular and the maximum size of segment becomes 4 GB. Okay. Where is DPL? Where is it placed? Where is DPL? Descriptor privilege level. Yes, where is the DPL, descriptor privilege level, in what we had seen that? See, these are the questions which will come in oral. If you want, you can note them down later on. This kind of questions will only come, and otherwise about the programs and all those. In online exam also, if it is online, we don't know what is the format of your exam. This kind of questions come. Okay. Yes, what is the DPL, where it is placed? It is placed in the segment descriptor, isn't it? We had seen in the segment descriptor DPL, descriptor privilege level. Okay. Okay, what happens in segment translation? Which address is converted to which address?
Logical address is converted to linear address.
That's correct. In segment translation, logical address is converted to linear address. Okay. Okay, so we have revised many concepts related to unit 3. Okay. So we'll continue further. Okay. See, few of you are answering, remaining also be attentive. You also have to give the exam. It is not that only specific students have to give the exam. So I want everyone to be involved in during the discussions. So if you have not understood, you can ask question. I'll explain it again. Okay? But study properly for the exams. Okay? I've shared the PPTs. Everything is there in the PPT. Okay? Yes, is the screen visible?
Yes, sir.
Okay. Okay, so we had started with page translation. So page translation is conversion of linear address to physical address. Okay, we had seen that yesterday. I just started the previous slide itself. Okay, so we had seen that page translation is linear address into physical address. When do we say that paging is enabled? How can we say that paging is enabled? From where you get whether paging is enabled or not? Yes, how do you get whether paging is enabled or disabled? PG bit is set to 1, that's correct. If the PG bit of the CR0 register is set to 1, paging is enabled. If the PG bit is 0, paging is disabled. So page translation will happen only when the paging bit is set to 1. If the paging bit is set to 0, paging will not happen and the linear address will itself be the physical address. Okay? Okay. So this address transformation implements the basic features needed for page-oriented virtual memory systems. So for page-oriented virtual memory systems, this particular page translation is used, and it also provides page level protection. So security is provided because of paging. Okay. Page translation is optional as we discussed just now. It is on effect only when the PG bit of CR0 is set. So when the PG bit is set, that time only paging will be enabled. This bit is typically set by the operating system during software initialization. So the operating system basically sets this bit of the CR0 register when it wants to enable paging. Okay. When we discuss the page frame, a page frame is a 4 kilobyte unit of contiguous, remember this, contiguous addresses of physical memory. So it is a contiguous unit of 4 kilobyte page. Okay, page frame specifically speaking. Pages begin on 4 kilobyte boundaries and are fixed in size. Each page is always of 4 kilobyte. Okay. Now we look at page translation. So the input to the page translation is the linear address. The linear address is the input to the page translation, which is the output of segment translation. Okay. So a linear address contains a directory part, a table part, and an offset part. So linear address contains three parts: a directory part which is 10 bit, a table part which is again 10 bit, and an offset part which is 12 bit. Okay. So the addressing mechanism uses dir field, that is directory part, as an index into a page directory. So the dir field is an index into the page directory. So there is a page directory present in page translation whose index is stored in the dir field of the linear address. Okay. The base address of the page directory is stored in the CR3 register, control register 3, which is also called as PDBR, page directory base register. Okay. Control register 3 is also called as PDBR, page directory base register. It contains the base address of the page directory. Okay. And the dir field or the directory field of the linear address contains the index in the page directory. Okay. So the page directory index is contained in the dir field or directory field. Then the entry in the page directory that it points to contains the base address of a page table. The page directory entry contains the index, the base address of page table. Then there is a page field in the or page table field in the linear address next part. This is the page table field. Okay. It contains index to the page table. Okay, it contains an index into the page table determined by the page directory. Okay, page directory points to the page table, and the page table entry in the linear address contains index to the page table. Okay. And the page table entry in the page table, it contains the basically the base address of the page that is to be accessed. So this is the base address of the page that is to be currently accessed. Okay. Each entry in the page directory is of 32 bit. So page directory entry is 32 bit. Page table entry is also 32 bit. Okay. Size of a page directory has 1024 and 1K, that is 1K entries are there in page directory, and each entry is of 32 bit, that is 4 bytes. So the size of a page directory is basically 4 bytes into basically 1 KB. So it is 4 MB basically. Okay. Yes, how much it will be? 1024. It is 1K into 4 byte. It is 4 kilobyte, not 4 MB. Sorry, it is 4 kilobyte. 1K into 4 bytes is 4 kilobytes. Size of a page directory is 4 kilobytes. Okay. Similarly, page table also contains 1024 entries, each of 4 bytes. That is 1K into 4 is 4 kilobyte. Size of a page table is also 4 kilobyte. And size of a page is also, as you know, 4 kilobyte. Okay. So page directory contains 1024 entries of page directory entries. Okay. And page table also contains 1024 entries. 1024 is 2 raised to 10. So that's why the dir field or the directory field is of 10 bits. You can have index from the 10 bits of the dir field. The page field or the table field in the linear address is also of 10 bits because 2 raised to 10 is 1024. You can have 1024 indexes from the table part of the linear address. And the offset is the offset within the page. Which memory location within the page is to be accessed is given by the offset in the linear address. So the page is of 4 kilobyte, isn't it? One page is of 4 kilobyte. Okay. One page is of 4 kilobyte. So the offset is of 12 bit because 2 raised to 12 is 4 kilobyte. So one of the locations in the 4 kilobyte page is identified by the offset. I know it is a bit advanced, but understand the basics. Okay. This is also an important part of your subject, page translation. So page translation is the conversion of linear address to physical address. The actual location in the memory is found in the physical address. So the output of the page translation will be the basically your physical address. Okay, output of the page translation will be your physical address. You'll get the physical address in the output of page translation. Yes, students, getting an idea about what is page translation at least. I know it is a bit advanced. This whole subject is in lot of depth. Okay, you'll have to take a bit effort, read the PPTs and you'll understand again, revise the concepts. Okay, so linear address to physical address is happening when page translation happens. It happens only when the PG bit is set. Okay, so linear address contains dir field, page table related field and offset. Dir field is 10 bits, page related field is page table related field is 10 bits and offset is 12 bits, total 32 bit linear address. There is a page directory containing 1024 entries of size 4 kilobyte and the base address of the page directory is stored in the CR3 register. Okay, control register 3, that is PDBR, page directory base register. It shows the base address of the page directory. And the directory field finds the index in the page directory. Okay. So the page directory entry is of 32 bit. Okay. The page directory entry contains the base address of the page table. Okay. Then the page field entry of the linear address is of 10 bit. It contains the index in the page table. Okay. And the page table contains the base address of the page, and the offset in the linear address, 12-bit offset, contains the offset in the page. Actual physical address is added and you get the offset in the page that you are trying to access. So that is the physical address. Okay. Yes, students, are you getting the concepts of page translation? I know it is a bit advanced. It is happening inside the processor, everything. But just visualize it and you'll get a better idea of it. I just shown you the diagram also. Okay. So this is the way page translation happens. Okay. So this is the way the page translation happens. This is the paging mechanism of the 80386DX. Yes, student, getting an idea about what is paging at least. This will happen only when the paging is enabled using PG bit is set to 1. Okay. I know it is a bit advanced, but just focus on the concept and you'll get the idea of it. Revise it again from the slides. Okay, you'll get better idea from that. Yes, students, getting an idea about paging. See, if time permits, we'll revise some of the concepts again. Okay, we don't know when the exams are there, but if time permits, we may revise something again. But till that, we have to cover the syllabus. Okay, so that's why accordingly I am trying to cover it. Okay, so you also be attentive. Read the PPTs once the teaching has been done so that you understand it better. Okay. Okay. So the size of a page directory is 4 kilobyte. It contains 1024 entries, page directory entries. Each entry is of 32 bit. Page table is also of 4 kilobyte. It contains 1024 entries, each of 4 byte, 32 bits that is. Okay. And basically, page directory entries contain the base address of the page table. Page table entries contain the base address of the page. Okay. And the base address of page directory is stored in the PDBR, page directory base register. Okay. So basically, page directory contains the base address of page table. Page table entry contains the base address of page, and the base address of page directory is contained in the CR3 register, page directory base register. The index in the page directory is contained in the dir field of the linear address. Okay. Then the index in the page table is contained in the page field or table field of the linear address. Okay. And the offset in the page that is actually getting accessed is contained in the offset of the linear address. So in paging, from the linear address, you are getting actually the physical address. You get the physical address in the main memory. Okay. From the paging, we get the physical address from the page translation. If the paging is disabled, the linear address is directly the physical address. Okay. Yes, students, clear now? See, I know it is advanced, but just focus on it. Okay. Then you will get the idea, better idea of what it is basically. Okay. And you read it later on from the PPTs I already shared in the Google Classroom. Okay. Okay. So speaking about the page table, a page table is simply an array of 32-bit page specifiers. Okay. It is each entry in the page table is of 32-bit. Two levels of tables are used to address a page of memory. So two levels, page directory and page table. There are two tables for accessing the paging mechanism. At the higher level is a page directory. The page directory addresses up to 1000 page tables of the second level. 1024 specifically speaking, that is 1K entries are there in a page directory. A page table of the second level addresses up to 1K pages. So in the page table also there are 1K entries. All the tables addressed by one page directory therefore can address 1 mega pages 2 raised to 20. 1024 in 1K in page directory, 1K in page table, multiplication of that is 1M pages. 1 mega pages can be accessed by paging mechanism of one page directory. So one page directory can access 1 mega pages 2 raised to 20. Because each page contains 4 kilobytes, 2 raised to 12 bytes, the tables of one page directory can span the entire physical address space of the 80386. That is 2 raised to 32. 2 raised to 20 into 2 raised to 12, that is 4 gigabytes. 2 raised to 32 is how much? 4 gigabytes. So the entire physical address space of the 80386DX can be accessed by one page directory. Okay, so that is about the page table. Okay, and speaking about the page directory entry and page table entry. So as I told you, page directory entry contains the base address of page table. Okay, so page directory entry, it contains the base address of page table. 20 bits are used for addressing the base address of page table. Then there are some security related bits also in the page directory entry. User supervisor, read write and present. These bits are for security in the paging. We'll discuss that in the next unit. Remember this: user supervisor, U/S, then R/W read write and present bit, and also the accessed bit. These are some of the security related bits and dirty bit. We'll discuss this in the next unit. These are all related to security. Mainly user slash supervisor, U/S and R/W are more used related to page level security. Okay. Then the page table, so page directory entries of 32-bit basically. Page directory entries of 32-bit. 1024 such entries are present in the page directory. Okay. Then the page table entry is also of 32-bit. Okay. So we are talking about this. Page directory entry means we are talking about this entry. Each entry in the page directory. And page table entry, we are talking about this entry in the page table. The page table entry is also of 32-bit, which is in the page table, stored in the page table. It also contains the base address of the page. Page directory entry contains the base address of page table, and page table entry contains the base address of page. It is also a 20-bit value. Okay. Page table entry also contains U/S, R/W and P bit for page level security. And it also contains the dirty and accessed bit in the page table entry. These are all related to security in paging, page level security. Okay, so this is about the page directory entry and page table entry. Okay, this is how page directory entry and page table entry looks like. Okay. Getting the format of page directory entry and page, we'll go in details of the security bits later. At the moment we are interested only in the base address of page table in the page directory entry and base address of page in the page table entry. Each is of 20 bit. Page directory entry base address of page table is of 20 bit, and in page table entry the base address of page is of 20 bit. And then you have u/s and r/w for page level security bits, and access, dirty bits and present bit are also present, okay, in the page directory entry and page table entry. Okay, getting the format of page directory entry and page table entry, there are 1024 such page directory entries in page directory and 1024 such page table entries in the page table. Okay, and total there are 1 mega such entries, such pages are accessed using these two tables, and each page is of 4 kilobyte. Okay, yes students, getting the concept? You read the entries later on in the PPTs that I have shared. Okay, I hope everybody has received the programs that I shared for reference. I'll share the concepts related PPT also in the Google Classroom of the practical lab. Okay, so there you'll get the theory part also in it. Okay, I share the lab manual in 1 or 2 days. We don't know how much you have to write, so I cannot officially tell you what will be the write-ups you will contain. That has not been decided yet, but I've seen to it that it is not big. Lab manual has been kept short. Okay, and I'll be sharing the programs for your reference also, so that once I teach you, you can refer, but don't copy it as it is. Just refer it and write your own programs, modify them and then use them. Okay, so be careful about that. Because time is less, that's why I'm sharing them for your reference. Ideally it is you that you have to design it, but we don't have time now, that's why I'm sharing for reference purpose. Okay, okay, yes, clear with page directory entry and page table entry? Okay, so this is the combination of both segment translation and page translation. The upper part is the segment translation, which converts the logical address to linear address. So this is the linear address, which contains three parts: directory field, page field and offset. Directory field is 10 bit, page field is 10 bit and offset is 12 bit. And then if the paging PG bit is enabled, there is the page translation which happens. Page translation converts the linear address to the basically to the physical address. So segment translation converts the 48-bit logical address to the linear address, and the page translation, if it is enabled, it converts the linear address to the physical address using the page directory and page table. In the page directory, you have the 32-bit page directory entry. We saw that format just now. It is 1024 such entries in the page directory. And in the page table also, you have 32-bit page table entry, which contains the base address of page, 20-bit base address of page. Page directory entry contains the 20-bit base address of page table, Okay, and it contains the users slash supervisor, read slash write, access, dirty bits, and so on. 32-bit entries are there in the each page directory. 32-bit, and there are such 1024 entries in the page directory. The base address of page directory is stored in the CR3 register, control register 3, that is the page directory base register. Okay, so this is the total segment translation and page translation given together in combining segment and page translation. Okay, so if they ask you give the combining segment and page translation, you will have to draw this diagram and explain in brief. Okay, combining segment and page translation. Okay, so we have almost covered the unit 3 now. Okay, any difficulties anybody has about segment translation, page translation, or any other concepts in unit 3? I hope you understood the concepts. Okay. So we have completed the unit 3. Now in the unit 4, we have protection related concepts. So how this segmentation and paging are giving protection for the 80386DX. All those concepts, all this DPL, RPL and all those concepts, segment descriptor, segment, how it is protected in 80386DX. Those concepts are given in unit 4. It is hardware level protection that is available in the Intel processors. Okay, so those concepts are given in complete in unit 4, protection related concepts. Okay, so in the next month first week you will have the unit test on first 3 units. Okay, unit 1, 2 and 3 you will have a 30 marks unit test online. Okay, your university exam timetable is not yet displayed or available, so we don't know exactly when is your in-sem and final exam. So whenever we get that, accordingly we'll inform you. Okay, and you don't have practical exam for this lab, you have a oral exam. In the previous syllabus they had practical exam, so there were a lot of problems. Only 25% of the students used to run the program for this lab. So normally we had to take oral and assess that student. So they have now kept oral only directly. So that is one thing that is a less of a worry to you, that you have to run the programs and then show the output, because it's a bit advanced programming. So many students used, some of them used to do it properly, but many of them used to struggle in the laboratories because a small mistake and the error used to come. Okay, so that is one of the changes that they have made. They have not kept a practical exam, they have kept a oral exam for this particular subject. But that doesn't mean that you don't have to study. You have to study the programs properly, theory of the programs, and you have to answer the questions. Okay, okay students, are you clear with unit 3? Okay, just give me a couple of minutes, I'll just take your attendance.